that's what this is. So think of this as a cooking recipe. So you have a bunch of factors that go into this analysis tool to spit out our EY. So there are several other factors, but the most important things to remember are these 5 items. Your envelope loads, which is your building shell, how is it placed in the site, and what is the shape of it, and what kind of fenestration it has. Do you have a sunshade or not? That's what envelope loads are, because that directly impacts your heating and cooling loads, right? And then internal loads. Lighting is an internal load, miscellaneous equipment, PCs and whatnot. So we'll talk about that. That's internal load. And these are the systems, what type of mechanical systems you have. Utility rates, that's very important to know, to spit out EUI. And operations, how long your building is operated. Is it operated during the entire school year? I mean, entire year, or is it only a 9-month school? So you need to know these 5 major items to figure out your EUI. And the only way right now, there is no easy button, so the only way right now to find out what your EUI is to take all this information and use one of the tools to find your EUI. This is your building's design, not the average building. Because the average building, again, you can get that information from Energy Star without having to going through any of this, right? So you start to see the complexity of this with all these different items. But at the initial stage, we don't have to get as complicated as it may seem. So now I'll talk about that. So far, everyone good on this sheet? Okay. All right. So let's talk about some of these. I guess we don't want to talk. Okay. So envelope loads contribute to heating and cooling, right? Form, shape, orientation, windows, fenestration, and the assemblies. What type of walls do we have? What type of roof do we have? And then internal loads, we talked about people. Remember how much do one person put out heat-wise? Do you guys remember from week 1? Huh? 1. But what is that in terms of heat energy?
2 light bulbs. Good one.
Yeah. So you have to cool that much energy, because every person that you have to cool them. So there's heating part for people, but there's also ventilation part, because we need to keep providing them fresh air. So if you have a huge number of people, you not only have to cool them with a lot of heat that they are producing, but you also have to provide them with ventilation. And then lights, again the same thing, they have power and heat. And equipment, they have power and heat. And then the last internal load item is the domestic hot water, right? And when it comes to systems, you have several different types of systems. You have controls, and you have automation of these systems, right? So there's a lot of complexity that could get involved right here under systems. When it comes to operations, it could be as simple as, am I a full year school or a 9-month school? From there, and you can get all the way down to, am I starting at 8 o'clock in the morning and am I closing at 3 o'clock? You can get down to that level of detail. And how many weekends do I have this building operated? So that's the other extreme of detail. And then the last one, utility rates, you can dumb it down to just say this many dollars or cents per kilowatt hour, or this many cents per term, or you could get into the demand charges and the seasonal rates. So look at all these things. There's multiple ways to get complicated and not get any results, right? Do you guys acknowledge that? So us as a design team, how do you deal with this complexity? We have an answer. Okay, so I'm going to try to relate this to our design phase. So if you know the zip code and square footage, when do you know this?
Usually the programming at the beginning.
Okay, so you know this. Then you can find average building EUI, right? Then if you know some sort of a adjacency diagram, or some kind of massing ideas that you want based on the program, and some site constraints. If you know those information, and if you also know some understanding of budget, when do you typically know all that information? Early schematics or during schematics. Then, if you know those information, we can find out what we just talked about, the distribution of EUI, and we can find out the best assemblies, best wall for your design, or the best shape and form for your design first, and then the best wall or best roof for your design, and then the best internal loads, meaning how do you manage the lights, how do you manage the amount of people, because by now you should have a rough idea of your code plan. So if you know your rough idea of code plan, what information does that give you?
Occupant load.
Occupant load. And why is that important?
You know how many BTUs?
How many BTUs to cool these people, but also ventilation, right?
Well, some of the stuff on the code plan's not, actual versus the square footage occupancy.
Right, and we can spend a day on discussing that topic. But the gist of it is, our designs have to be designed for worst case, right? Worst case, I could have 150 people in a media center or something. So my mechanical system should be able to handle that 150 people. But theoretically, that could only be 26, 30 people every hour.
Mostly I was referring to the classroom spaces versus,
Right.
The actual, how many
Actual.
they put in.
So that will be an issue. But in general terms, you should know how many people your facility is going to have by then. So if you know that, then you don't get into any more detail of exactly the detail that you were saying. You don't get into that detail at this stage because you're not trying to estimate the exact energy consumption for your owner. What are we trying to do with the EUI? We're trying to inform our design because that's the most important part here, right? So once you know that, then maybe after the schematic design, when you get into detailed design development, you start to understand the owner preferences on terms of mechanical systems, in terms of what they would like as far as maintenance goes. So then that's the time to find out what type of system makes more sense from an EUI, and how do you optimize the operations of the building to get the most energy or to be more energy efficient. And then that's the time to do life cycle analysis. So majority of what we as architectural profession would do will be above this line. We will not get into this at all. Do you guys follow that? So far good?
Say that again?
Majority of what we as an architectural profession would do will be above this line. We would want to find out what the best shape of the building. We would want to find out the envelope loads. How do you reduce that? And we want to find out how to manage the internal load standpoint through natural ventilation and daylighting and whatnot. So we'll talk about all that in the future classes. Yes?
I have a question. If you start with a generic EUI, and in design phase you go through all the process of trying to bring it down, how can you find out where it goes if EUI is just based on zip code and square footage? How do you know the progress you've made before you actually have actual numbers?
Right, and that's what I'm saying. This average building EUI is not your design. This is just what's out there in the world. In order to find your design, we need to do energy analysis. There's no other way.
So there's not another...
There's no easy button.
Okay.
Unfortunately, we have to put all these ingredients that I talked about.
I guess that's still a problem.
Yeah.
If your average is built on such generic numbers,
Mhm.
you do your actual energy model that are built on a lot of different variables and numbers, then
Yeah.
are those two really comparable?
Yes. The reason is, regardless of, that's where design comes into play. What's out there is based on the function and some of the other parameters that you put in, right? So let's say, just in Phoenix zip code 85016, let's say there's 10 different offices, and you're designing an office building, right? The 10 different offices could have handled their EUI several different ways. But what matters is what is their final consumption and how low our consumption can go. So regardless of how they have built their buildings, whether it's CMU or stucco or whatever, it doesn't matter to us. What matters to us is what is their energy consumption, which is the average for us for this zip code. And we have to be below that through our design. Does that make sense?
An
Yeah.
example would be loss cleanest with how our design, we went one way, but other firms to still meet the 20% below could have done
Several
three
different
things.
several
And
different things.
By doing the life cycle costs and that stuff, we finally narrowed our choices down to one
Right.
path. And we're still above what we're supposed to, but it's doing a whole building approach versus walls being a certain R value in the roof.
Right.
And
I guess one thing I'm wondering though is also, you said there's 20 different ways to get to a one number. Should we be really looking at Energy Star? I mean, I guess we can look at that as just generic, now I know it, but should we start creating our own database so we can start comparing it to our own work so we can start using our own?
Actually,
That's why we're doing it, right? To compare
Yeah, that's
it.
why we're starting to do all these things. We are building our database.
Are we
but I
going to
g-
track any?
Huh?
Are we going to log any of the old buildings?
Yes, our electrical guys have done their part on tracking some of these buildings. But the larger issue is, I think it's important to understand that regardless of how the buildings are built out there, it is important to understand what are they consuming. So then, because to come up with the building's energy consumption, as you noticed, there's million factors. So there's no way we're going to find an exact match of our building that we're trying to design with CME walls and whatnot. You cannot find an example that even our own building database won't be the same. Because every building is totally different. So because the operations are different, the space planning could be different, even different prototypes of the same building, different zip codes, it could be totally different. Different orientations. So even our own database is not going to help us a whole lot. It's going to give us more information, but the ultimate is to understand where we need to be, and then come up with different ways to solve that or reach that point. Does that make sense?
It's 12:55.
Okay, I'm going to run through this really quick.